Hello, welcome to a new video tutorial. My name is Juan D'Amico, I'm an economist, and in my channel you're going to find videos about applied time series analysis and forecasting. So if that is something that you're interested in, please feel free to subscribe to my channel. Now in today's video, I'm going to show you how you can expand the simple RBC model and add exogenous oil supply. So in this example, what we are going to do is going to introduce a new input in the production function of the firms. So now they are going to demand oil in the production function. Now, when we do this, we are going to obtain a price for oil. We're going to define an equation for the oil production, and then we are going to rewrite the dynamic equations of the model. Next, we calibrate the parameters of the model, and we derive the impulse response functions. As you can see, in this model, we have a demand shock, and we also have a supply shock. The idea in this tutorial then is to understand the dynamics of oil prices when there is a demand shock. This is when the economy is growing and the firms need more inputs to produce output. When this happens, they are going to demand more oil. Now, what we know is that when the demand for an input increases, the price for the input increases, right? This is just common sense. If you need more oil, eventually the price of oil is going to start going up. And this is what we see here in these results. I'm going to zoom a little bit so you can see the results. And you can see that demand shock on oil prices has a positive effect. Now, when we scroll down, here you can see a supply shock. A supply shock means that the supply of oil is going to increase more than what the economy is demanding. Let's suppose, for example, that increases a lot the productivity, or the firms find new oil reserves, or anything that can result in an excess of supply from the producers. You can see that what's going to happen with the oil prices then, anytime that the oil supply increases, you can see here, when the oil supply increases, you can see that the oil prices decrease, right? So that's also common sense, as I just mentioned. When there is more supply of oil than what you demand, then, there's an excess of supply, the prices are going to go down. Now, this is a very interesting model that I find very useful, so you can understand how you can expand a simple real business cycle model and incorporate new inputs. Incorporating new inputs is going to produce different outputs, and this is what we are seeing here. Now, what you can do then? Well, we can produce an out-of-sample forecast for the price of oil. We can forecast the GDP cycle, in this case is for the United States, and we can generate one-step ahead predictions. In the end of this paper, I provide you with some ideas to improve the model. So the purpose now is we're going to go into the board. I'm going to show you how to derive the model, and then you can go ahead in Stata on your own. You can grab the simple RBC model. There is a link in the description of the video where you can download the dynamic equations. I also put the link for the video tutorial of the simple RBC model. So then what you can do is you can set up the simple RBC model, and after watching this video, you can expand the simple RBC model and incorporate oil in the production function. After you do this, what you can do is you can improve the model, making oil supply endogenous. I'm going to talk a little bit more about what is endogenous and exogenous oil supply in the tutorial. And also in the description of the video, you can find a link where you can buy this file. You can obtain as well the math from the slides on the video that I'm going to proceed now in the board. And you're going to get also the Stata file to be able to produce all these graphics that you are seeing in here. So that's something that if you're interested in, you can buy it, and also you're going to help my channel to keep growing. I don't get any funding for doing these videos, so a great way of supporting more content creation is, of course, buying the material. You can also subscribe to any of my memberships, where you will also contributing on a monthly basis to my channel. So without further ado, let's get into the board and let's start deriving this model. All right, we are in the board and I'm going to show you how to solve the model. So the only difference that we're going to have in the oil model is in the firms function. All right, so the only difference in this model is going to be observed in the firm's production function. Now, why is there a difference in the firm's production function? Let's recall the basic model, this simple RBC, that we have that the output was equal to a technology shock, capital. We also need workers, we need hours of work. In some textbooks, you're going to find it with an N, with an L. It all depends whether it's number of workers, hours worked, labor, whatever is the letter they are using, it doesn't change the facts. So we're going to use HT for hours worked. We're going to keep consistent with the way we wrote our simple RBC model. And now the new thing, the innovative thing is now firms are also going to be oil in the production function. So let's think about this. Sounds pretty realistic to believe that the firms, we're gonna put this is a technology shock. All right, this is the technology shock. This is the capital that the firms need. This is our workers. Let's just put workers. It's gonna make it easier. These are the workers, and this is oil. All right. Now the question that should come to your minds is, who is supplying oil in this model? Who is supplying oil in the model? And that's a very important question, because it's going to define whether we're going to be introducing a very complex equation to determine how oil is supplied into the model, or we're going to leave it as exogenous. So let's keep here then. We're going to put OT, right? Let's see. This, it's OT, can be then, we're going to say, can be endogenous, sorry, let's begin with endogenous, or it can be exogenous. Now, by endogenous, what I mean is that there's going to be a function, there's going to be something that is going to, we'll need to maximize, and we'll need to understand what are the defining equations for the way oil is being supplied. For example, maybe there is a shock, technology shock, let's say set T. Maybe they also need capital, so let's call it OT, because it's capital, it's not this capital, it's oil capital. And then maybe it needs also workers, so here is going to be called OT, right? So what I'm trying to say by this is there's going to be some more stuff to work on, to maximize, and to model as well. But something we can also do, and it's pretty realistic as well, and we're going to discuss a little bit more about this in the next page, but it's just leaving this exogenous, meaning it's not determined in the model, right? It's we cannot determine, all right, what triggers or what causes oil shocks. All right, and in this case, we are going to be putting an equation of oil supply that would look something like this, for example. Set T, and let's call it MT. where set T is going to follow an AR1 process. All right, I'm going to use this notation as we use it in Stata. So we get here the following. I'm just writing an AR1 equation plus an error term. All right. So in this case, we're leaving the oil supply being exogenous. All right, and this MT is just a constant, which normally is calibrated to 0.5. This is very common when we leave something exogenous in the model. And that's about it. MT can be oil endowments. So let's put a name. Let's just assume, right? We're just making a model. We're just assuming things. I'm going to call these endowments, all right? Oil endowments. So there we go. So for this case, for our model, we're going to be working with an exogenous oil supply. It's going to make it way easier. It's going to make it way more straightforward. But let's analyze a tiny bit more here what exogenous means. When we are talking about exogenous oil supply, I'm just exogenous oil supply, we mean is that the supply is going to be inelastic. What does it mean inelastic? It won't respond to, it's not going to respond to shocks. And in this case, it won't respond to shocks. In this case, to demand shocks. Okay, it's not going to respond to demand shocks. Now, what are we going to see in the model? For example, when there is, sorry about that. Let me just clean this here. There we go. So what I mean with this is that when there is a demand shock, and for example, let's suppose here it's called oil demand. We see that it does something like this. All right, I'm just playing around. All right, what's going to happen then if this is exogenous is that the oil supply is going to, it should look something like this, empty, legit. You're going to see nothing. So I'm gonna say oil supply. All right, oil supply is gonna look empty. There won't be anything. All right. So that's what an exogenous oil supply is gonna imply. In terms of thinking about this in economic terms, it can be realistic that the oil supply, that the oil shocks are exogenous because we don't know what's triggering an oil shock. So oil shocks are hard to predict. All right. So what can be an oil shock? For example, can be war, right? It can be something that is unexpected production failures. It can be political events. There's many oil models that try to incorporate and measure how political events are going to affect oil prices. It can be problems with oil endowments, oil reserves. So there can be many factors that can affect the way that oil supply behaves. So all these things are okay to assume that they're going to be exogenous. We don't really know. Like, do you know when a war is going to happen? I don't know. Do you know when there's going to be a production failure? I don't know it. Do you know when there's going to be a political event? No, I have no idea. Do you know when, for example, they're going to find more oil reserves? I have no idea. So all these things can be determined exogenous, all right? So that's what's cool, and that's what's half realistic to assume at least that the oil shocks are going to be exogenous. Now, let's keep working then in the model. Let's keep working on the maximization problem. So we are going to have the following. We have that the firms are going to maximize. So let's just put it this way. We said this is the function, all right? This is alpha 1, alpha 2, alpha 3, subject to, and we have that the firms have to pay wages for each hour of work, right? Plus, they'll have to pay returns on the capital. These are returns on the capital, plus they will have to pay a price. Here, this QT is going to be equal to the price of the oil barrel, and OT it's equal to oil, right? So let's recap. We have the firms need to pay wages for each hour of work. They need to pay returns for the capital they are demanding, and they need to pay a price for each oil barrel they are going to demand for production. So when we go to the maximization problem, we're going to put the following. They need to maximize capital, hours work, capital, and OLT. And we're going to write the following. AT, KT, HT, OT. Here we have alpha 1, alpha 2, alpha 3, minus this, minus the constraint. This is the constraint. So we have RT, KT, minus QT, OT. All this has to be equal to 0. So first order conditions. So we have the derivative of the profit function with respect to capital. And this is going to be the following. We have alpha 1, AT, KT, alpha 1 minus 1, all right, there we go, minus RT. Now let's do the following with hours worked. And now we have, instead of alpha 1, we have alpha 2, AT, KT, alpha 1. Here we have HT, alpha 2 minus 1, OT, minus WT. And then we have, with respect to oil, so we have alpha 3, it's all the same. KT alpha 1, HT alpha 2, OT alpha 3 minus 1, and here we got the price of oil, right? Let's do an abbreviation. So if you see all this, all right, is equal to YT already, all right? That's all these things can be expressed as the production function, all right? So I'm gonna go into the next page and we are going to keep working on this. We have from the first expression then, we can solve for RT. I'm gonna put 1. So RT is going to be equals to alpha 1. Sorry, let's grab the eraser here. Let's start again. We have alpha 1. We have YT over KT. Now the second equation we have is that wages is going to be equal to alpha 2 YT over hours worked. And the third equation is the price of oil. And the price of oil is going to be equal to alpha 3 YT over OT. Let's grab some color here. This is the first one, this is the second one, and this is the third equation. Let's clear this here. Perfect. All right, so that's all, guys. That's perfect. That's what we got. That's the equations. Now, let's go back to the following. We need to write the equation for oil. So the equation for oil, we said it was going to be, which I already explained this, all right? It's an exogenous oil supply, where said it's going to follow an AR1 process. I already explained this in the previous slide. And this is the behavioral equation. Now let's go into the next page, because we're going to write all the dynamic equations. So basically, I'm not going to repeat all of them. I'm just going to write here dynamic equations. Dynamic equations. And the only equations that we need to add into the model, the only things that you're going to be modifying in your RBC model are the following. The first, of course, is the production function, because now the production function is the following. All right, so that's the production function. These are the things you need to modify in your simple RBC model. The next thing we need to do is, okay, who is supplying oil? It's exogenous, we said. All right, so we'll do like that. You need to add into your model. What else do we need to add into our model? Well, now we also have oil price. So oil price is going to be the following. Perfect. What else do we have to add? Well, the next thing we need to add, and I'm going to write it again, although I already wrote it a couple of times, is the productivity, the shock of the oil firms here, of the oil supply, sorry. So these are the equations that you're going to be adding into your simple RBC model. Let me write it again. You guys already know this from seeing me write it many times, but there we go. Set T plus, and here we have, I'm gonna write this, and let's put this the oil shock, all right? Oil exogenous shock. All right, so that's gonna be all pretty much for the model itself. Some of the things that we can see maybe is how we're going to calibration of the parameters, so then you can go ahead into Stata and modify the simple RBC that we already seen, and incorporate the following stuff. So for alpha 1, we're going to assume a value of 0.3. For alpha 2, you're going to assume a value of 0.65. For alpha 3, of course, it's going to be whatever is left over from here. And the last thing that we need is oil endowments, that I said already is going to be 0.5. So this is going to be basically all the math in the model. Now let's go back into the slides and let's conclude with this tutorial. So that's going to be all for today. I hope that you find it useful. I hope that you now understand how from a simple RBC model, you can expand the model to incorporate oil. You can do the same, for example, using other inputs. For example, if you want to use gold, or if you want to use any sort of minerals, if you want to use any commodities, for example, if your country is, for example, exports soy, or they export other sort of commodities, it can be any commodity really. You can just, instead of using oil, you can use another commodity. What else can I say? If there's any doubts, you can also send me an email. You can leave your comments, please, here. And well, I hope to see you in the next tutorial. So please feel free to subscribe to my channel. We're going to keep creating. I'm gonna keep bringing more and more and more content about applied time series analysis and forecasting. So please give a like, and I'll see you on the next tutorial.